Here we're going to solve a series of rational inequalities, starting with the quantity 5x plus 15 divided by the quantity x minus 8 less than 0. Here the vertical asymptote is x equals 8. The horizontal asymptote is y equals 5. The y-intercept is equal to negative 15/8, and the x-intercept is equal to negative 3. Now, for those values, please go back and review the previous video. So we're going to draw the vertical line x equals 8, the horizontal line y equals 5, the x-intercept at negative 15/8, and the x-intercept at negative 3. The curve is going to be coming through the bottom left portion created by the intersection of the two asymptotes and the top right portion. And we are to compare this with 0. We want to know where this function is strictly less than y equals 0. And so that is where the curve is below the x-axis. And so we have this section in here as well as over here. As a matter of fact, it will include the numbers between negative 3 and 8, not including either of the endpoints, because the function is 0 at negative 3 and undefined at x equals 8. The graph of this would have negative 3, 8, open circles at both of those, and a segment in between. So the next example also is the quotient of two linear functions, and so we'll have both a vertical and horizontal asymptote. The vertical asymptote is going to be x equals 1. The horizontal, y equals 2. That's the quotient of the leading coefficients. The y-intercept is going to be negative 1, where x equals 0, and the x-intercept is going to be negative 1/2, because that's the 0 of the numerator. So vertical asymptote at x equals 1, horizontal asymptote at y equals 2, y-intercept at negative 1, x-intercept at negative 1/2. So the hyperbola is sitting in a very similar way to what it was sitting in the last example. This time we want to know where is the rational function, the y value, less than or equal to 3. And so I also have to draw in the line y equals 3, which would be approximately here. And we want to know where are the y values in the hyperbola less than or equal to 3. So we have that situation over to the right of where the two functions intersect, and that's where y equals 3, and I will let you confirm that x would have to equal 4 when y equals 3. And then we have all of the values less than x equals 1 as well. So we're going to have the interval from negative infinity up to 1, not including 1 because the function is undefined there, union, and it's less than or equal to 3 that we're looking for, so we can include x equals 4, and then from there we go to infinity. So on the number line, we'll have an open circle at 1 and a closed circle at 4. We'll have a ray going to the left from 1 and to the right from 4. The third example, the rational function has vertical asymptote, x equals 7, horizontal, y equals negative 1, y-intercept 1, and x-intercept negative 7. So drawing in x equals 7 and the point negative 7, 0. We also have the y-intercept at 1 and the horizontal asymptote at y equals negative 1. This time, the branches of the hyperbola are in the top left and bottom right. And we are comparing the values of y from the hyperbola with the line y equals 1. And ask to find where is the hyperbola on or above the line y equals 1. And that occurs starting at x equals 0 and going all the way up to x equals 7. And so in this case, we will have the interval from 0 to 7, including 0 but not 7. 7 cannot be included because it is not part of the domain. 0 can be included because the value of the function is, of the rational function, is 0 at x equal, is 1 at x equals 0. Our last example is a little bit different. Our rational function is y equals 36 over x. Vertical asymptote, x equals 0, horizontal y equals 0, no intercepts. But it has been stretched. So one of the points in the right-hand branch is 136, and in the left-hand branch is -1, -36. Now, I'm not going to pretend that I'm drawing this to scale. But we will have a curve like this. Now, the value that we are comparing this with is y equals x. Now, this is not going to look like a slope of 1, but bear with me if you will. And so this is representing the line y equals x, not to scale, as I said before. And we are to find the values of the hyperbola that are below the values of the line. And so where do these values occur? They occur to the right of this intersection and between this intersection and x equals 0. So we need to find these two intersection points. They are 6, 6 and -6, -6, setting 36 over x equal to x. We get 36 equals x squared, x equals plus or minus 6, and because y equals x, the x and y's have to be equal. So this time our solution are the values, and we need strictly under. So from -6 to 0, not including either of those, union from 6 to infinity, not including either of those. And so on the number line, we'll have -6, 0, 6, all with open circles. The interval from -6 to 0 will include a segment between those two open circles, and then a ray to the right of 6 going to infinity. And that will describe where the solutions of the inequality 36 over x less than x occur.